Greetings, welcome to this new video about superposition theorem. Solve the problem number 10. In this video, I will demonstrate the application of the superposition method to solve a problem, and I will guide you through the step-by-step process of using superposition to solve the problem at hand. Let's consider this network consisting of two resistors labeled R1 and R2, as well as two independent sources. Additionally, we can observe the presence of a dependent source, especially a voltage-controlled voltage source. The question now is to use the superposition method to find the voltage VO across the resistor R2. Let's move on to the solution. First, we begin by identifying each independent source in this circuit. This step provides a clear understanding of the source that will be analyzed separately. In this circuit, we can observe two independent current sources, IA and IB. Next, we proceed to deactivate all but one independent source in the circuits. This involves replacing the inactive voltage sources with short circuits, which mean zero voltage, and the current sources with an open circuits, which means zero current. Let's begin by activating the independent current source IA and deactivating the independent current source IB, which will be replaced by an open circuit. Like we see here, there is no current flow in this direction. That means the current flow in the resistor R2 is IA. Now, according to Ohm's law, the voltage V1 across the resistor R2 is equal to R2 times IA. And if we replace R2 and IA with their numerical values, we obtain V1 is equal to 30 volt. Now let's consider the independent current source IB active and the independent current source IA inactive, which will be replaced by an open circuit. Like we see here, there is no current flow in this direction because here it's an open circuit. That means IB is the current flow through the resistor R2. Now, according to Ohm's law, we have V2 is equal to negative R2 IB, and if we replace R2 and IB with their numerical values, we obtain finally V2 is equal to negative 40 volt. After completing the analysis for each independent source while treating the other as turned off, the subsequent step is to combine the result algebraically. This process enables us to determine the overall circuit response. That means VO is equal to V1 plus V2, and if we replace V1 and V2 with their numerical values, we obtain finally VO, the voltage across the resistor R2 is equal to negative 10 volt. After we finish the calculation, we conduct a simulation using a SPICE simulator in order to verify our results. Let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here is the independent current source IA, the independent current source IB, the voltage controlled voltage source, resistor R1 and the resistor R2. Let's move on to analysis. This analysis calculate nodal voltage. We can see here the voltage across the resistor R2 is equal to negative 10 volt. After completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves a validation of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about superposition method. Take care and bye bye.